Yeah. Okay. Good morning, everybody. I think it's 11 o'clock. I propose that we start with the webinar. My name is Carola van der Meij. I'm a team leader, cruise and ferry within Marin, and I have the honor to be your host today. Today will be a day about wind assisted propulsion for ships. And I'm here standing in the Marin studio in Wageningen in the Netherlands. This morning will be a Wasp webinar where all the work package leaders come together and discuss the project aims and objectives and challenges and successes up to the date at the moment. And also look into the pathway to the forward for wind propulsion systems. This afternoon, we have the WISP workshop. WISP is a joint industry project which has recently finished. And we will be presenting our results and discuss also future developments in the wind assisted propulsion. If you want to join the WISP workshop later this afternoon, it starts at 1:30 and you can register through the second link on the program. For now, the co-host for this today will be Craig Eason, and Craig Eason will take charge of the whole WASP part of this morning. Craig is a former officer and trained broadcast journalist. He worked for the BBC and other broadcasters before sending about 12 years as the technical editor and deputy editor of Lloyd's Register List, where he focused on growing environmental and sustainable questions and regulations in shipping. Today, he owns and edits the Fathom, world's website focused on the transformation of shipping, which clearly also covered the evolution of wind assisted and wind propulsion. He is also host of the Aeronex podcast, which can be found on many audio platforms and has already covered a number of the developments and companies that are pushing wind as a viable future in the shipping. I hope to see some of you later this afternoon also in the workshop. And now enjoy the morning, and Craig, the floor is yours.
Thank you very much, Carola. Thank you. Good morning, everybody, and good morning to our panelists who will be giving their insights and intelligence far more than I will be able to during the course of this morning's event. We've got 5 or 6 presentations or speeches coming up, so we're going to go through them fairly quickly. On the system, you will see there is the ability to ask questions and answers, and we can go to more in-depth Q&A afterwards. We've got a long period to allow for discussion and debate over what we're going to hear from the panelists over the course of over the first part of the day. So as we go through this, I want to see the questions coming in. I'll be asking questions, of course, as is my prerogative as moderator of this event, to make sure this thing flows properly. I'm not going to talk anymore now. I'm going to hand over first to Gavin Allwright, who's Secretary General of the International Windship Association, which many of you, of course, know as this non-for-profit organisation dedicated to the promotion of direct wind energy and wind assist propulsion systems. So, Gavin, I'll hand over to you immediately, I think, so that we can go straight on with the presentations, and then we can get into the discussion and debate later on. Gavin, over to you.
Yeah, thank you very much, Craig. Can you see my slides here?
Yes, we can.
Fantastic. Okay, so I have the luxury, if you like, to give or the privilege to give the overview of the WASP project. So I head up the communications, the work package 2, and also help with advisory work on the other work packages. And as you'll see here, this is a half-funded or part-funded EU Interreg project, and the total budget is just over 5 million euros. This is obviously focused on the installation of wind propulsion systems or wind assist systems onto 5 different ships. And one of the key objectives there is to have these installations out there as demonstrators of the technologies, but also validating the performance data, etc., etc. So collecting a lot of data around these installations. We have 3 so far. Another one is happening over the weekend, and the 5th one will be actually delivered in May, I believe. So also identifying viable business cases and looking at how to scale this up, and the facilitation of a level playing field, which is obviously has a lot of synergies with what IWSA is doing, and we're obviously inputting into that. The partners on the project, there's 14 partners. I think there are the 5 ship owners. We have 2 NGOs and associations, including IWSA. There are 4 universities involved, the R&D testing center at SSPA, and the finance specialists at HHX Blue. And the project lead are the Netherlands Maritime Technology Foundation. This is actually a picture of the Scandlines MV Copenhagen, which was recently, or middle of last year, installed and has been testing that as we go forward. So the project cycles basically follows a fairly standard project cycle, but the real core here are these installations and the ability to use this as a small test fleet for both the technologies, but also the validation, research, etc. that goes around this. And one of those key objectives is obviously to get that market adaptation update, and uptake of the wind propulsion systems in the North Sea region. This is just a very quick slide on the installations. 2021, obviously, for the Roebraren and Tarsis Sea River shipping installations, as I mentioned before. We've got a sort of swathe of different sized vessels here, with different systems or different configurations of the same system being put in there. This is the Frisian Sea, which has also recently been installed. The project structure. Now we're going to actually hear from work packages 3, 4, and 5. So I'm not going to talk too much about those, but you'll be hearing about the engineering, policy, and the viable business structures, and the performance validation as well. And these results, you'll see this copied again in a couple of the presentations, basically demonstrating the usability of the 5 wind systems, validating prediction tools, and then that further market uptake. So it's really applied. It's not just pure research. And these are the actual direct result indicators. So there will be tons of fuel saved, tons of CO2 saved as well. But really that is important. But this stimulation of the market and proving of the systems for the market is the really impactful result that will be had. So with that, hopefully that's given you a rough idea of what is going on, and I'll hand over to the other presenters.
Thank you very much, Gavin. And if you could stop sharing your screen. Our next speaker is going to be Joshua Lacey, who is assistant professor at KU Leuven, and he is head of work package 3 on engineering. And his work includes, at KU Leuven, includes fundamental experiments, numerical modeling, high level stuff, which is the kind of stuff you'd expect from an assistant professor. I point out that Gavin and I are the only 2 who don't have professor, assistant professor, or doctor in our names during the course of this webinar. So we are vastly outnumbered in levels of intelligence here. But Joshua, could I ask you to share your screen, please, so you can start your presentation to see that's working properly?
All right, hopefully everybody can see that.
Yes, we can.
Just get into presentation view. Okay, so thanks for that introduction, Craig. So yeah, as Craig said, I'm Assistant Professor Joshua Lacey, and I'm in charge of Work Package 3. So Work Package 3 is concerned with the engineering of wind propulsion technologies, which of course you can see clearly from the title slide. Now, what does that mean? Well, there's a couple different aspects to this. So first and foremost, the goal of this work package is to prepare ship owners for the installation and then for the operation of these different wind propulsion technologies. So what does that consist of? Well, first, of course, is the preparation of the vessels for these installations, but also investigating some of the practical implications of using these technologies. And the way that we want to do that is using some numerical tools. And these are tools that we're developing to be able not only to perform calculations of CO2 avoided and of energy saved, thrust developed basically as a result of using the wind propulsion technologies, but also to validate these numerical tools with real world logged data from these ships to be able to use them as performance predictors for other scenarios, for instance, for other voyages where there's other wind profiles that are present. So it's kind of a twofold purpose there. And then really from these numerical studies, again, which will be validated using real world measured data from the ships, we want to take that acquired knowledge and we really want to be able to inform ship owners to say, given some particular configuration with your conventional propulsion system and your wind propulsion technology, what is the optimal way to operate the propulsion system for the ship to get the greatest savings of fuel consumption and the most CO2 avoided. So to really, we want to provide that kind of understanding to ship owners. So not only what the optimal operation is, but really what is the potential for savings? And the idea being that showing that lots of savings are possible will obviously encourage the uptake of the technologies. So this slide is just a brief overview of the research institutions or the knowledge institutions that are involved. So myself, KU Leuven, we're in the lead of this work package along with Chalmers and SSPA. So KU Leuven and Chalmers are developing those numerical tools scattered amongst the 5 ship owner partners. So developing the numerical framework to be able to model these ships and to also be able to do determinations of the savings of CO2 and fuel consumption reduced. And SSPA is helping to coordinate with, of course, all these ship owner partners to be able to get us that log data in order to use that to be able to develop the models. And they're also participating as well in hosting a number of workshops related to legislative and safety considerations that come along with the installation of these wind propulsion technologies, because in addition to the technical feasibility, of course, the legal feasibility is equally important. So there's a few specific technologies that we're looking at across these 5 ships. So I've listed these here: Flettner rotors, suction sail. So some of you might have heard of this as a turbo sail. That's sort of a trademarked name. So I use the name suction sail here just to be more general, as well as a 2-element rigid wing sail. So we have a few different technologies that we're looking at. And not only that, these 5 ships all have not only different physical configurations, but they also have different conventional propulsion systems as well. So there's a really quite a nice opportunity to investigate the interaction and the interplay between the wind propulsion technology, between the kind of alternative propulsion system and the conventional propulsion system, and really the optimal solution or optimal operating pathway for each one of these ships, of course, is going to be different. The solution will be different depending on what kind of technologies you implement. This is just a very brief idea of the kinds of results that we expect to generate, and in fact, some initial results that we've generated from these models. These kinds of polar plots are actually common to those of you familiar with sailing. And the idea here is you have a ship here in the middle that has some particular heading, and what you can see is for some particular wind propulsion technology that is deployed, and based on the direction of the wind with respect to the heading of the ship and the speed of that wind, how much savings that you can expect to realize. And of course, so these 2 plots are at one particular condition, so one wind direction and one wind speed. And so you can imagine that if you integrate a lot of these polar plots over the entirety of a journey, then you're able to determine a total amount of fuel savings or carbon dioxide or greenhouse gas emissions avoided. So that's just an example of some of the tangible results that we hope to deliver with these numerical tools. So that's my brief overview of work package 3. So I suppose I will return the ball back to Craig.
Thank you very much, Josh. Thank you for that introduction to work package 3. So if you could stop sharing your slides, and Sophia, if I could ask you to open your webcam. We can't quite see you at the moment. And if possible, share your screen. I think Sophia has probably got the best backdrop of any of us today. I believe that's the test tank at SSPA, is it, Sophia?
Yeah, that's correct. That's our towing tank.
Great, great. Could I ask you to start sharing your screen, please, Sophia?
Sure. So we are going straight to work package 5 and not 4?
No, we go straight to you, and then we go to work package 4.
All right, no problem.
And then because
yes.
we got two people talking about work package 4. So you first,
No
Sophia.
Yeah.
So, and while you're doing that, I'll just introduce you. Sophia is the PhD naval architect at an SSPA in Gothenburg, Sweden, focusing on hull design, CFD, model testing, full-scale trials and performance monitoring, the sort of stuff you'd expect from an expert at SSPA, I guess. And she's currently focusing on wind propulsion and sailing ships and leading SSPA's R&D within ship performance assessment. So Sophia, perfect person to hand over to about work package 5.
Thank you. Yes, so work package 5, that's about the trials and monitoring and evaluating the performance of these technologies in full scale. So if the other work package 3 and 4 deal with what comes before the installation and preparing the ship owners, work package 5 is or what happens after installation. How can we validate the performance of these technologies? Demonstrate the usability and send back the information back to the pre-installation work package dealing with the tools so that they can validate their tools, and it goes around in the loop. So the main objective of the trials that we will carry out, that's really to confirm the fuel saving. So it's not to verify the absolute level of the power consumption, but it's just the saving. So we really want to compare the performance of the energy consumption with and without the wind propulsion technology. That's really the aim of the full-scale test that we will do. And we are a bit lucky here that all 5 technologies that we test, it can either be turned off or on, like the Flettner rotors can simply be stopped. So they're not rotating anymore, then producing no force. Or in some cases, even the wings can be lowered down or tilted. So that makes it's a bit easy for us to compare the ship with and without the technology. So there are 2 ways to set up these full-scale trials. Either we look at monitoring the performance for a long period, like before the installation, compared to a longer period after the installation. Another way is to go for more short, dedicated tests. And the disadvantage with the first methodology is, as probably many know, that the monitoring data that we can get from ships is often very, very scattered. So it's difficult to draw some conclusions. Moreover, it can easily happen that the ship went on a different route, had different weather conditions before and after the technology was installed. Maybe we even have different hull conditions because the ship was docked during the installation, or somewhere in the between. So it's quite difficult to extract small differences here using monitoring of longer periods. If we go for the short dedicated tests, short here I mean maybe magnitude of an hour or even shorter or a few hours, then we can expect that the quality is better. We can run with the device or technology turned on for 1 hour and then lower it or turn it off for 1 hour continue on the same course and same weather and same speed. So the quality of the measured data will be better, but of course we will only get exactly that, the performance of that weather condition. And maybe we can do a few of those tests, but it will still not cover the whole, all expected weather conditions that the ship can experience. So anyway, we have to sort of extrapolate this result to get the expected full year fuel consumption. So there are pros and cons of both these methods, but we have decided in this project to go mainly for the short tests. And here are some examples of the tests that we have already started to do. So the left plot here is a track of Scandlines Ferry Copenhagen when we did the sea trials using double runs. And we also developed a new method to evaluate the double runs, not only in beam wind, but also in other wind directions. And we will come back to that with, at a later stage. And the right-hand plot is from another ship where they did some short test during operation. So during a trip, just took 1 hour off the schedule, went up and down in a few directions, and then just continue on the route. So these are the kind of tests that we will carry out for all the 5 ships in the project. But monitoring longer periods and also some sister ships comparison, if that's possible, is of course also very useful, and it will be done in parallel in the project. So that during, for example, 1 year of operation, that can answer other type of questions like when was the technology used and when was it not used? Why was it not used? Was it because of weather or maintenance? Did they have any unexpected events or risks? How did the crew experience this technology and so on? So these kind of questions I think we can only answer by monitoring for a long period, over a year, and collecting the experience. So with this combination of the short and the long-term trials, I think we will cover most aspects and get a good validation of the performance. And I will be happy to answer questions after the presentations. Thank you.
Thank you very much, Sophia. I'm thinking of questions. I see there's one question coming in already. I'll save that until later, if I may, Sophia. I think, and everybody else is, we've got about 100, we've got over 100 people actually on this webinar at the moment. So if you're going to, and I hope you do, put questions into the Q&A, if possible, could you indicate who you want me to ask that question to, so that it saves us a little bit of time. I'm hoping for a flood of questions, having so many people listening to this webinar. So please put them into the Q&A, but try and indicate who I should ask the question to. And just a reminder, reminders just popped up there, just to remind you all again, I'll do this at the end of the webinar, just to remind you about the workshop this afternoon. This is WASP, this afternoon is WISP for the workshop. So please, could you, if you're interested in that, make sure you've registered for that, because it is a completely separate Zoom link. And if you look in the chat, you may see a Zoom link has appeared. Anyway, having said that, thank you very much again, Sophia. Vasilios Cosmos is from the Hapag Lloyd Center for Shipping and Global Logistics and Kuna Logistics University. So I can see you're already sharing your slides. That's perfect. So could I hand over to you directly then, please?
Thank you, Greg. Good morning also from my side. I'm Vasilios Cosmos from Kuna Logistics University, and I'm really happy to be here and present to you briefly what we are doing in Work Package 4, Policy and Viable Business. I hope you can see my slides. So,
yeah, we can.
Perfect. The overall objective of Work Package 4 is the resolution of business and regulatory issues in order to promote the uptake of WASP technologies within the shipping industry. You can see briefly the key activities that we are focusing on. To begin with, one of the key activities is the development of a viable WASP business case. And in this regard, we are cooperating together with the 5 shipping companies in order to identify what factors need to be taken into account when designing the business case and what factors influence its viability. We have identified so far key drivers that move companies towards investing in WASP technologies, how companies can also be incentivized towards this direction, and incentives are still limited within the industry. We also have identified the importance of an effective decision-making process within the company and specifically between the top management and the technical experts as well. And lastly, we have also identified the importance of other stakeholders that can influence the viability of the business case. Such stakeholders are, for instance, the shipping crew, the insurance companies, and classification societies as well. Moving on, as in any other new innovative technology, there are certain barriers that prevent the uptake of such technologies in the industry, and therefore Work Package 4 focuses on the development of potential strategies in order to overcome such barriers. Linked to these barriers, and specifically to the issue of access to capital for ship owners to invest in such technologies, Work Package 4 develops also innovative financing solutions towards this direction. Moreover, about another barrier, which relates to the urgent need for verified information regarding the actual implications and operational performance of the technologies in general in the industry. The Work Package 4 deals with the quantification of the economic and socioeconomic implications, and also looks into how the WASP technologies can be diffused within the sector under various scenarios by taking into account the constant interactions among the stakeholders and the actual operational performance. We cannot leave out of the discussion the importance of raising policy awareness in order to promote and highlight the potential role that WASP technologies can have within the decarbonization discussion of the sector. And given all the above activities and their associated findings, we plan to develop a business decision support model that hopefully will be used by ship owners that are interested in exploring further WASP installations on board of their vessels. If you would like to learn in more detail of what we have done so far, please have a look at our output library on the project's webpage. And there you can find a recent report that compiles all the recent WASP adoptions in the industry. And although there is still a limited number of adoptions, we have identified a promising trend of diffusion of the technologies in the sector. Moreover, you will find a recent research paper that provides a detailed economic and operational review of the wind assisted sea propulsion technology in the industry, but also you will see what are our suggestions to policymakers towards promoting the uptake of WASP technologies in the industry. I kept it really short, and thank you for your attention.
Thank you very much, Vasilios. And that was one part of Work Package 4. I'm going to hand over now to Professor Dr. Orestis Shintsas from, I can't remember where you're from, actually, do you know, Orestis? But if you could, I believe you're actually you haven't got any slides, so you're just going to talk to us about the finance element of Work Package 4 now. So if I could just hand over directly to you, please. That's right, HHX. Sorry, I completely missed that bit. So Orestis, over to you, please.
I had a tiny problem with my connection. Can you see and receive well?
We
from my
can.
end?
I can see you. I can hear you.
Okay, great. So HHX Blue is participating in the WASP project, and we cooperate with IWSA and with Gavin personally for many years long. So we are, I think that we are one of the first companies that is on board on, let's say, the wind assist technologies. And we believe in this wind assist technologies for various reasons, but allow me to focus on the financial aspects, and especially on the financial issues that relate directly to the project WASP. Allow me to remind you that the value of the assets, let's say the ships currently in the water, is around $2.2 trillion. And as per the current regulatory requirements, the ones that we expect to have in MFSC 76 and in the near future, almost 80% to 90%, depending on the ship type and size, will not comply with the regulations of EEXI, the Energy Efficiency Operating Index, and the carbon intensity index. And this gives a huge, let's say, trigger for financiers and operators to invest in shipping assets again. And this is, let's say, what this is also the outcome of the studies and the input that we get from classification societies, where practically 90% of the total fleet, of the existing total fleet, does not comply with the EEDI phase 3 requirements. In this regard, bank lending and generally available capital for debt is decreasing from banks due to banking and financial regulatory, let's say, issues. So the leverage of the industry is still 50%. And that means, I mean, right now I'm talking about across segments and sectors. So, and that means that it is really challenging for ship owners capital in order to retrofit, or let's say to update the technology on board, or let's say to build new ships. And this is challenging. We have concluded an analysis that will be published soon, where around 300 billion is the cost of the estimated decarbonization effort in assets for the period 2025-2030. That is, let's say, the first period to the compliance with the 2030 goals of the IMO. And we have, as I said, this figure is very close to what other sources estimate. So you can have a range from 250 to 350, only for, let's say, new ships or retrofit in this period. And keep in mind that the order book right now, most yards worldwide, is, let's say, empty. To cut a very long story short, if we estimate 300 billion, that is, let's say, the total amount of cost for decarbonization and to achieve the goals of IMO 2030, and considering that wind assist technologies are already in, let's say, in the list of technologies that are promoted by classification societies, technical experts, etc., etc. And if we consider that only 10% of this budget will be allocated to wind assist technologies, why? Because it is easy to, let's say, retrofit, because it is easy to install, because there is already knowledge and technology and how to, then we can see that a new market of 30 billion potential is, let's say, generated. And this is a very interesting point for our colleagues working on the technical aspects for WASP, because unless we have credible data from a technical point of view, unless we have, let's say, credible data on the energy, let's say, savings, on the operating profiles, unless, let's say, we do our technical homework properly, then our financial calculations are more speculative than, let's say, very well substantiated. So this is a very important point. And along with this, let's say, financial aspect that we contribute in the WASP, we also contribute the pay as you save, and right now we develop also the pay as you use, models that the pay-as-you-use will also be available shortly and published. And this is, let's say, our contribution to the new SIP financing universe that is under development. The new SIP financing universe will be based on leasing schemes, will be based on shared economy schemes. And of course, there are different approaches. Let's say the pay-as-you-use that could fit, let's say, the very big organizations and technology providers, or the pay-as-you-save that could be also very friendly to small companies and also to ship owners. But generally, what we see is that we see a hybridization of the technologies. Let's say a combination of technologies, let's say existing technologies like diesel electric and wind assist technology on board the ship. And all this modularity should be served by new financial models and new financial tools. And this is, let's say, what we contribute. And we hope that till the end of the project, we will have, let's say, a substantial footprint. Last but not least, due to, let's say, my personal capacity as head of a delegation of a member state of the IMO, we have contributed along with other colleagues in the WASP, and we have, let's say, submitted a document in the MFC 75, and we have also submitted documents in this MFC 76 in order to facilitate the promotion of the wind assist technologies. And this is, let's say, a side effect of, let's say, of our network. That's all from my side. Thank you.
Great. Thank you very much, Orestis, for that introduction. And I'm going to ask everybody, all the panelists now, to bring up their webcams, if they would be so kind. And to remind everybody who's listening to start asking your questions. We've got about 50 minutes to have Q&A now. So we've got plenty of time for questions. And given the scope that we've just heard from the various experts, these questions can be as technical and scientific as you like them, and they could be as more general as you like them as well. So a couple of the questions that sprung to mind, I'm going to start with you, Orestis, as you've just spoken last. I just wanted to ask you a little bit more about that financing aspect that you see when you're looking at what's going on with this project, with this North European project, with the WASP project, and you look at the global goals that we're looking for. It was interesting that you picked up on the sort of basically the model of renting the technology, isn't it? It's a form of pay as you sail. It's like you don't own the technology on the ship, but you rent it, you put it onto the vessel, and it gives you the fuel savings. How difficult is that discussion going to be when it comes to integrating that into an existing shipping model where you've got a lot of different actors who are involved in a shipping industry, charterers, owners, cargo owners, and that? Do you envisage this being a particularly difficult conversation?
The answer is, the answer could be yes and no at the same time, because it depends on who is, let's say, your client, and it depends on the technology. Definitely, we're going to have more leasing models, and I mean more leasing business models, because that suits the needs of the big manufacturers as well. And we can see also that there are some deals already in the market where there is leasing of equipment, even of attached equipment. And this is very important because we have to make the difference if it is, let's say, attached or detached equipment on board. From a legal perspective, that is critical. And we can see that there is a trend to go to more leasing schemes. Why? Because there is no available capital. We're not back in the 90s, for example, or in the early 2000s, where you can go to the bank and say, hey, I have 10, 15% of equity, I need the rest as a debt. That's not possible anymore. And as long as there is no fresh capital available, then we have to find new business models. The point is that what you promise as ship owner to the technology provider, and what the technology provider is also promising to the ship owner, is that you're going to get a share out of the risk and the benefit of the fuel savings. So yes, Mr. Ship owner, if you install my technology, then you're going to save so much fuel, and this means less fuel in terms of cost, and at the same time less CO2, and CO2 has a price. So this is important. And the pay-as-you-use, or let's say the leasing schemes that are based on the use of the equipment, these are already here in the industry. This is nothing new. So what we have to do is that we have to give to the financial world to understand the capacity of the industry. When I mean industry, I mean the wind assisted technologies industry, and that owners and charters and users are willing to install these technologies. And I think that we are right now climbing the curve of maturity. So there are many positive signals, especially in the northern part of Europe, and especially where, let's say, WASP as Northern European Indirect Project is concerned. There are many projects in the region where wind assist technologies are considered, but as part of a hybrid solution, not, let's say, as a key propulsion solution.
Yeah, it's an integrated part of what an owner is going. But if I take that my question just one step further, go on, carry on.
No, please.
My other part to that question was some of the technology companies that are developing these solutions, they're not necessarily large companies with a lot of capital themselves. So when it comes to taking on board some of the risk that you're talking about, do they themselves have the capital to take on board that risk, or will they themselves, would you expect them to then look at their own financing model as a technology company to be able to share that risk and the reward, as you say, that they would look at when they install a kind of pay-as-you-sail model with a ship owner?
And this is, this is a decision that should be faced by the technology providers. They have invested time and for even, let's say, own resources, let's say, funds and capital for the development of the company. But however, corporate solutions require also corporate, let's say, strategies. So if you have to merge, if you have to acquire or get acquired, this is part of the game. And when you have a tiny facility where you do not even have the money to demonstrate your technology, or let's say to take the risk for, I don't know, 6, 5, 10, 8 months to support the technology, then how can you expect the ship owners or anybody else to buy your technology? This is very important. And I have personally been in the very difficult situation to explain to a technology provider that unless you grow big, unless you have, let's say, some financial capacity, then you cannot proceed. And this is everywhere in shipping. This is not, I mean, in all industries.
No, I understand. I understand that. I'm going to go to a question. Well, I've got a couple of questions now that I think are aimed towards Sophia and to Joshua. How transferable to other WASP technologies, not trialed in the WASP project, so other wind solutions, I guess, are the results? Could, for example, there be an output of the WASP project to enable comparative assessment of different technologies as part of a feasibility of wind assist installations? So in other words, can you comment a little bit about how those examples, those tests that you're doing, Sophia, Josh, on vessels as part of the WASP, how is that learning going to be extrapolated to other technology providers within this field? Can I start with Sophia, please?
Yeah, sure. Yeah, so what we develop is methods to evaluate both before installation and after installation. So it's that's really the outcome from our side. So the methods will be applicable to other types of technologies. So we are preparing the market for other technologies in that way. So yeah.
The answer for you is yeah. Joshua, have you got anything else to add on that?
Yeah, I mean, yes, so Sophie's answer is actually very comprehensive. I mean, I think the only thing I'd perhaps add is, of course, there's always in a scientific sense, you always have to be careful when you extrapolate. But again, one of the, the big deliverables or the big outcomes of this is to provide these numerical tools to give some sense of the savings that are possible. So you can think of it as maybe not this are the exact savings you're going to get, but at least an envelope of least to most amount, somewhere in there, just to at least be able to provide some data for a feasibility study, whether or not some future technology is going to be investable or not. I think it at least gives you a shot at doing that.
And just taking that further and just going into Manish's question here, is there to be an algorithm? And maybe I think there are possibly already some algorithms exist which will take inputs for wind speed, direction, turbulence, and will act to rotate sails accordingly to extract maximum power. So in other words, when you're looking at the sail operations, whether it automatically adjusts for the relevant conditions. And then a second part of that question, do we use wind thrust directly to move the ship? Or can we also use some kind of power converter to transfer energy when wind direction is not in favor of getting any thrust in direction of the sail? So in other words, I guess the question there is, while we're using wind as a source of thrust, if there isn't the right angle, can we turn the power of the wind into some sort of other power within the ship? I'm not sure who would pick up that question, but while you're there, Joshua, without your microphone muted, I'm going to pick on you.
No, that's fair. Maybe I can, provide some insight. To the first point, so that is something that we want to look at. Now, it's not necessarily a specific outcome to develop, an optimal control algorithm. But based on the log data that we do get from these sea trials, we do want to actually look again at the interplay between what's going on with a particular wind condition, how the wind propulsion technology should be operated to maximize thrust. And there's an even deeper question perhaps of, do you always want to maximize thrust? Because of course there's some other forces that act on that rigid element that can have some impact on the heading and the performance of the vessel. So that is another factor to consider when in the control algorithm. But that problem we do want to look at a little bit of again the interplay between the current wind condition and what the wind propulsion technology would be doing, because ultimately these systems will have to be automated. There's no way to guarantee maximum savings with sort of a manual operation of the sails. And I would say, maybe to even add to the point, there's also the idea of really a full system integration. So not only optimizing the operation of the sail or the wind propulsion technology, but also what the conventional propulsion system is doing as well, whether you're depowering the engine or deactivating or activating a diesel electric generator set. Again, that depends largely, or adjusting a propeller that has some ability to change its pitch. Whether we have variable pitch propeller, that largely, the optimal solution is absolutely dependent on the specific wind technology and underlying conventional propulsion technology.
And that, of course, would have to be done automatically, wouldn't it? So that it would be almost instantaneous.
Indeed. I mean, you could try to operate it manually, but the manual, because things are changing dynamically at sea conditions, wave, wind conditions, you would never, with a human operating it, you would almost never be operating at the optimal point. So ultimately these systems will have to be automated. And so it is an eventual goal. It's not necessarily a goal of what we're doing with our numerical tools, but it is something that we do want to directly investigate and to consider. And then I think there was as to the second point. So the intent here is to use the wind propulsion technology directly for thrust. So that's a direct conversion of the wind into a thrust that can be used to power the ship, not necessarily just to make it go faster, but really the intent is to use that amount of thrust and then run your engine at some lower power because the wind propulsion technology is providing some of the required power demand, you know, when you have a ship at a particular speed that you're trying to maintain. So, and again, as Sophia mentioned, these wind propulsion technologies can be turned essentially on and off. So when you're at an unoptimal or non-optimal wind condition, then you simply de-energize or you just turn off the wind propulsion technology. That's really the idea.
But that was one of the other questions we've got here that was put towards Sophia, is in full-scale measurements, was there any other expected or observed limitations for the available Wasp power at high wind speeds based on heeling angle or steerage? I guess it's the same thing as the old sailing ships in hitting a hurricane. You know, they reef down or reef up. Which way is it? I can't remember. So, I mean, what are your observations or expectations in high wind speeds, Sophia?
So, yeah, it depends a bit on different technologies, but some of them that can be tilted and lowered down, for sure, in really high wind speeds, they will be stored on deck. The flattener rotors are quite solid, and they will just stand by. When it comes to heel angle, what we've seen so far, it's the heel angles are quite moderate. It's not at all as on a sailing boat. So it's probably structural limitations that requires, of course, the reefing or lowering down the sails.
And when it comes to the sea trials, I've got a couple of questions here that are popping up relating to how we see things pan out. Do you have any expectations about how wind technologies will meet EEXI at the moment? I know there's a lot of discussion about how the EEXI is being calculated, and it at the moment, as it stands, it doesn't look too favorable for wind assist propulsion, simply because of the way it's being done. But I know, having spoken to Gavin about this, that there's a lot of work being done to try and raise the profile of wind propulsion here to make sure that it is seen as a viable solution. So can you add anything here about the protection of how the EEDI and EEXI could impact wind propulsion technologies in particular? And the other part of this question, which somebody else, Sandeep Patil, has asked here, is how much reduction in EEXI is possible with the wind assisted propulsion? I don't know whether you could answer those two questions together either. I guess this is a question for Joshua and for you as well, Sophia, in terms of how you expect wind assist propulsions to play a role in the EEXI calculations.
I think I can answer the question the other way around, but what we develop in terms of trials, methodology, procedures that will be needed to validate and verify the EEXI with the wind. So I think that's our contribution to that.
Yeah.
But your question, I think I will hand over to Josh.
Joshua, any comment on the EEXI? Are there any projections, or do you have any comments about EEXI? And if any other panelists have got any thoughts, just raise your hand and I'll add you as well. Joshua.
Yeah, I mean, you know, again, we'll the idea behind the work package 3, but really the overall project is to provide some sense of what kind of fuel consumption savings are possible, and then really to also make a calculation or estimation of the CO2 that's avoided. So yeah, I mean, I'd be loath to give specific numbers, of course. And again, this will be, you know, the idea is to give really an envelope of potential, right? To look at, in a worst case, in a best case scenario, what are the kinds of savings that we expect to find from these technologies, and again, also installed on ships of dramatically different physical configurations and dramatically different conventional propulsion configurations, because again, the answer will vary widely.
Yeah. Okay, I'm going to go over to Orestes. I see you have a comment, Orestes.
May I?
Yes, Orestes, please, you. Yes.
Yes, there are two different things. The EXI is let's say a regulation, and the very same way as you have a formula and a regulation that does not address all let's say physical situations or physical considerations and configurations of propulsion plants, etc. Then the same thing applies for the EXI. So I think that what you can see also in MEPC, where you have some member states that suggest, for example, an approach to the wind power and direction similar to the significant height as we have, let's say, for maneuvering and seakeeping. Something like that will, let's say, come into the regulatory framework pretty soon. But in actual conditions, this is something different. So EXI, EEDI, this is the regulation. This is what you get on the certificate. This is what, let's say, makes your ship seaworthy on camp, or let's say puts something in the nominator of the EEDI or EXI formula. But in the actual conditions, what we get from, let's say, owners who have already installed wind assist technologies is that they have a really good and promising plus, let's say, a range of a minimum 5, maximum 15. This is what we have got, let's say, from owners on the actual savings. And this is at least what we consider in our calculations. So the EEDI, EXI, it's regulation, classification societies, the ones who provide the certificates or the design ships, they can, let's say, base the calculations. But when you have financial stuff and all these relationships, then you need also some experience from the market. And the more we get experiences from the market, then the better is our statistical estimation.
Good. Thank you very much, Orestes. Gavin.
Yeah, I'm not going to go too in detail with the EEDI and EEXI, but I just wanted to, and if anybody's really interested in that debate, the workshop this afternoon is also going to be touching on a lot of this stuff, which is part of the WISP project. What I did want to say is that the WASP project has a collaboration going on with WISP around some of the validation work, and Sophia's working with them on that to try and come up with the some standard validation approaches. I will say that the EEDI and the EEXI, or especially the EEDI as it stands now, is not fit for purpose when it comes to assessments of wind propulsion. Just for an example, assessments are made regarding flat sea conditions. You actually want to be you want to be setting benchmarks around with the least wind involved if you're doing a motor vessel. But also the global wind matrix is a big issue as well. That it's taking an average across the world rather than route specific, but also it's classed as wind at around a deck level, sea level, whereas you've got wind systems that could be very, very much higher than that. If you're coming into kites, then you're actually looking at sort of 200 meters up, and it certainly doesn't take that into consideration. So there is a lot of work going on, and as Orestes mentioned, there are a number of submissions going in around EEDI and for MEPC 76, and EEXI will be following in MEPC 77.
Good. Thank you very much there, Gavin. And I just wanted to move on then to some sort of slightly different questions, because I'm aware we've got a few questions to go through. We've still got half an hour left here, so put your comments and questions into the Q&A so that I can see them and ask them to the panelists, please. I've got one. It just follows on actually quite nicely from what you were saying there, Gavin. Bertrand Charrier has written, I'm concerned by the validity of the sea trials when the percentage of energy saved is limited just a few percentage points because the size of the wind propeller or system is limited. What kind of incentives will convince some ship owners to install 3 to 4 onto their ship, or propulsion systems onto their ship. In other words, not to go for single systems, but to go for 3 or 4 systems. I think really in terms of that, I actually want to ask Vasilios for your comments on that, please. Because here we're talking about the business case for not hedging your bets and just going for one system on a ship, but going the whole hog, as we say in England, and installing 3 or 4 systems on a ship in one go to maximize the benefits that you can get from a wind propulsion system. So if you could give us some comments, please, about that, how the test results indicate, I mean, as we heard Orestes say, something between 5 to 15%, although in my book, that's not necessarily an insignificant percentage. But if it's only 1 or 2 percentage points, if you put a single system onto a ship, and you could get up to that 15% or even more if you put more systems on board, but though at the same time, you're going for a greater risk. What is the business case? How can you reduce that risk in the business case? I guess I'm asking to encourage that kind of investment in these technologies.
That's an interesting question, and an ambitious one. To be honest, I mean, this is what we are trying also to look first by with the Wasp project, first by experimenting and exploring one technology at a time. Of course, we have seen also recent plans by shipping companies to have fully wind-propelled vessels that have been announced recently. This is also interesting, and we have to see how the operational performance of those systems will be in the end. When it comes now to the business case and the incentives, there are still limited incentives. And of course, the fuel savings play an important role, always in combination with the fuel prices in the market as well. Incentives, I mean, I saw also the next question, which also refers to the incentives, can be provided at this stage by policymakers, either in the form of subsidies, as is happening in the Wasp project, in order to explore the benefits and to see if actually the operational performance is sufficient, and the fuel savings as well. And then we can move on further with further exploration of Wasp technologies as well. But we cannot tell at the time if we install 3 or 4 technologies, if this will be a better option instead of one.
It would take a little bit of time. Gavin, do you have any other thoughts on that, given the fact that you've got an overview through the Windship Association on other projects and the way the whole industry, the whole windship industry is evolving?
Yeah, absolutely. There's a couple of points that I just wanted to follow up with what Vasilios was saying, and also the percentages that we're talking about here. Please remember that the 5 to 15%, 5 to 20% is based on a motor vessel operational profile. So that means the ship isn't being changed to optimize the wind system itself. It's simply being added to a motor vessel, and then the motor vessel is being operated pretty much the way it always is. So if you are then weather routing, if you are changing speeds, all of these other operational aspects could improve that. And also on the ROIs, as Vasilios is mentioning, we're also looking at the industry looking at Unit 1 or Unit 3 at the price spread for the units. We should really be looking at Unit 10, Unit 100, where the price is substantially reducing for these systems. Also, the fact that fuel prices are likely to be going up quite substantially in the coming years. As a spread, when you have new alternative fuels coming into the market, those prices are going to be increasing. If it's in the scope of what I'm seeing, 2 to 3 times more expensive than fuel today, plus you add in a carbon price for your regular fuel, you're starting to look at economic dynamics changing in favor of a zero emissions fuel or a zero emissions energy source, which is pretty much delivered to the ship without infrastructure and without the need for any additional expenses. So I would say that the market dynamics are shifting in a positive way towards wind propulsion.
Yep.
That doesn't necessarily manifest itself in the ROIs or the business case today.
Okay.
So that was the additional point I wanted to make.
I've got another, actually, I've got a comment here that just came in a second ago, and it's one that I just wanted to bring up a little bit here. It's basically relating to the CII, because from when I've been looking at the calculations, when I've been looking at the policy document and what the IMO has been talking about, when we look at the EEXI, as Orestes says, it's very much it's a calculation. It's not dissimilar to the EEDI. It's you get that formula, you meet that formula, you're done. You've got your tickets to trade, as far as I can see with that. The CII, however, is a lot more operational. This is something that a ship owner will have, like an A to E on the side of the fridge, coding to say this is how good the vessel is. Now, that is going to be a lot more operational. That's going to be a lot more kind of hands-on results. And this is where you put in your data into the IMO's data collection scheme, because don't forget, the CII is linked to the data collection that the IMO is doing. So this is going to give you this good CII will give you a good grading every other year, basically every year, although a year later, so that you will get a B, and then you got to get in, you know, it'll get better. So if you've got a wind assist propulsion, is this then going to be the key incentive policy-wise to drive wind propulsion forward? Is the CII the hidden rocket fuel that we need to push wind propulsion forward? And as you're actually, I'll go to Orestes, please, briefly on this, because you were the one that was talking about the EEXI and the policy side of this. Have you looked at the CII and how this can manipulate itself into the financing aspect of wind assist propulsion?
Yes, of course we have. And this is something that we consider in our business planning, in our, let's say, products that we develop for financing. So it is, I mean, it has a pivotal position. It has gained our core attention. And regardless of the criticism again, let's say the regulation, I can tell you that it is a tool that many people can understand the very same way as you said that we have the A to E ranking for refrigerators. I think that there are two different things. When you get, let's say, D or E, then you have to do something in order to, let's say, trade further. And then these wind assist technologies can help really to get this plus, let's say, 5% or 10% fuel savings that you need in order to improve your ranking from D to C or from E to C or B or whatever. So I think that, yes, this regulation can really boost decarbonizing technologies like the wind assist technologies. However, keep in mind that the wind assist technologies are competing against other technologies. So technology providers with with anti-fouling and let's say super duper coating, they are, let's say, playing against Wasp. There are other technologies like propeller efficiency technologies, etc., etc. But these are good news. Competition is always good. And when you can, let's say, combine technology, let's say, of propeller with wind assist technologies, and you have the data of colleagues like Josh, for example, then you have arguments and you have also the technical capacity to assess different hybrid solutions. So I think that yes, it can really boost. And going back to the subsidies, we have to be careful what we mean with subsidies. Subsidies for the development of the technology or subsidies for the promotion of the technology, because we have already the export credit facilities that provide the financial tools if necessary. So if, for example, we have Dutch or German or Norwegian technology, whatever, the national credit facilities, they can provide, let's say, the necessary financial incentives for the installations in the new buildings. But the big problem is what are we going to do with the retrofit? And this is where the EXI and the carbon and CII comes into the picture and give the incentive to the ship owner to invest in the retrofit.
Great, thank you very much for that. If any other panelists want to actually make any comments on that, please just wave your hands. Otherwise, I've got a few other questions. We've got 20 minutes left here, and I've got a few other questions on some of the other topics that I wanted to address. And one of those, I'm going to go now back to Sophia, and it's relating to weather routing and testing. Matt Smith has asked if there's any value in having an accurate wind measurement independent of the vessel's wind flow disturbance? And what about the shear and veer across the length of the sail? Does that have any interest? Would or could this refine the optimization of the assistance? And then I've got a question from Florent Bickert for Joshua and Sophia. Weather routing is a key element for wind-powered technologies. Do you take into account weather routing to evaluate the savings provided by a wind technology? And if so, how? So, Sophia, could I start with you on that first part of that question?
Sure.
On having accurate wind measurements independent of the vessel's wind flow disturbance, please.
Yeah, absolutely. And that we have already seen in some of the installations here, that it's very important to have a good and independent wind flow measurements for the control system of the wing or rotor or whatever it is, for the control system to take the right decision. It needs to know the right incoming flow. The disturbance of the hull is really great and much larger than many people expect. So, yeah.
Can I just elaborate on that a little bit? Because there was, when you gave your presentation, you alluded to doing wind tests with and without the system in operation. But did you do wind tests before the system was installed on the vessel? Because in some circumstances, even when it's non-operational, it could create a disturbance to the operation of or the performance of the vessel. So in other words, I'm asking about three conditions: the condition when before the wind assist solution was put on board, the wind assist solution being on board but not operational, and then operational.
Yeah, that's a good point. For example, the flattener rotor, even when it's not spinning, it creates a drag, which will affect the baseline reference case. But no, we did not do true baseline sea trials, and that would have been then under other weather conditions and other circumstances. And I think that the key for the really good accuracy here is that we do the trials in the same day on exactly the same conditions with and without the device. So I think that is the most important thing that reduces the uncertainty.
Okay, good. And have you got any comments about weather routing per se? Because I know there's a lot of work that's been going into weather routing and looking at how various systems may perform on various routes. But are you within the Wasp project? Are you looking at, is there any value in weather routing within the Wasp project?
So we don't study it as such, but it could come into the pre-installation prediction. So maybe over to Joshua.
Yeah, I mean, I was just thinking about that. Again, as Sophia said, so there's not a particular consideration of weather routing, but the numerical tools are fairly generic or general, if you want to think of them that way, in that they give you a predicted fuel savings at some particular condition. So you could use them, as Sophia said, as kind of a pre-installation or feasibility calculation to determine, if I do this installation of this technology and I take one route versus another, which might be slightly longer, but the wind conditions are more optimal, what's the potential for fuel savings for optimizing the route? That's like it's a very interesting optimal control problem, and it's a specific one that really could be extended and sort of from the use of these numerical tools, but it's not something we specifically consider.
Great, thank you.
Sorry, Craig, if I could just
go on, Gavin. Sure.
Just a little bit. You know, there's the weather routing, but there's also the weather forecasting as well, which there's quite a bit of work going on outside of WASP on satellite weather forecasting. And I've noted that there's been a test on the Yankee, which is the vessel behind me, of a LiDAR system as well. So that's creating some data around real off vessel wind systems coming in, or wind action coming in prior to, you know, it hitting the sails. So there's an element of optimization that can go on there as well in an operational sense. So that's already been going on. That's not incorporated actually into WASP per se, but Marin has been doing some work on that, and I'm sure that data will be available in the coming months too.
Great. Thank you, Gavin. I've got a question here for, I've got two questions here from Robert Tustin. One is for Vasilios and one effectively for Joshua. I'm going to start with the Vasilios first. How to address the issue of buy of a wind assist technology by ship owner with fuel saving benefits to the charter party. So this is the question about charter parties, which the whole what is it, landlord tenant discussion. So I guess the question is how to commercially incentivize the owner to buy the wind assist solution when you're looking at an owner, I guess, being in a charter trade. I mean, there's obviously different owners, different trades, different ways that they operate, own vessels and can invest in the vessels themselves. But the question here is specifically on a more tramp operation where you've got an owner, and let's not forget that most owners only own about 4 or 5 ships, and their vessels can be on a spot or voyage market. How can we address the issue of installing the technology when the charterer may not want to have that technology installed?
I mean, this split incentives issue is a general problem within the industry, which needs to be addressed, and has been proven to be like a barrier in investing in more environmentally friendly shipping in general. How can ship owners be incentivized? Of course, if it operates on the voyage rate, then the ship owner will benefit completely from the fuel savings. But when it's chartered out, then this will be an issue, and the companies that we are working together are hoping for a premium. But this is not always the case, as has been proven in the industry. How shipping companies can be incentivized in general, I mean, if in different ways, they can be incentivized by their customers as well. If the customers want to have more greener supply chains, then they can put more pressure on the shipping companies in order to invest in that. Other incentives can come from the policymakers, either in the form of subsidies, such as is happening in the WASP, but also through regulations that will internalize the external costs that are produced by the operations. So we need incentives in order to move forward with the installations of WASP technologies in general. Yeah, that's it.
I do know that the likes of BIMCO have developed clauses that allow for this kind of discussion when it comes to other areas, such as slow steaming. When you optimize the vessel's speed to get to the port effectively when the port can take the vessel in rather than sail and wait, which is obviously one of the clauses that has been pertinent to this problem, is the need to sail at the best speed to get to a port, but then only to find the port can't actually take the vessel in, and you've got to sit there and wait at anchor for a while. So there is an incentive there. Are you raising your hand, Gavin, because you wanted to add something to that?
Yeah, I am actually. You've stolen my thunder a little bit on that. I was gonna bring up the BIMCO issue. I just noticed that there's a clause, a standard clause adjustment for just-in-time arrivals, and that does certainly play into that. I think Orestes would also have some comments to make on this sort of package of incentives or incentivization for Wasp for ship owners as well. Orestes.
Thank you, Gavin, and I would like to focus on the question of the colleague Robert, I think, who asked the question. We don't need any special incentives. What the owners promise to the users, to the charterers under the time charter agreement is a speed and consumption warranty. So when you have a wind assist technology installed that, let's say, results in consuming 5, 10, X% less than your market, then the charterers have a clear interest in chartering your ship vis-a-vis the ships of the competitors. And this is very important when we are talking about the time charter markets. The only issue that we might face is in the container markets. There are not many Wasp technologies that can, let's say, serve the needs of container ships. That's why many expect the users, the shippers, to have, let's say, to pay for a premium. But so far, there is nothing like a premium in the market, and it's very difficult to influence or incentivize the global market. About, let's say, Trump shipping, it's the same thing, because owners have the inherent interest of saving fuels because what they sell is transport capacity and the taxi service. So what you see from BIMCO is terms about slow steaming that, and not only about slow steaming, but they try to make the life of time chartering, or let's say the life of those involved in time chartering, easier and updated to the modern technology. So what the colleague said about weather routing, so it is an excellent example. So if you have good data, if you have good systems, if you buy, let's say, good systems, then you can save more, of course, at the expense of having a longer period at sea, but then you can also meet the rendezvous, let's say, the time slot with the port. So this is what BIMCO is trying to do. But in my view, the only thing that we have to focus as a wind assist technology segment and sector in industry is to save as much as possible, because this is the real incentive to the users. This is it. And in the container business, about, let's say, premium for green service, I have never seen anything like that, personally.
Okay. Thank you. I've got a couple of questions here left. We've got 7 minutes left of the webinar. And I want to make sure that everybody gets the good hour before we go on to the workshop at 1:30. And just a reminder there, if you haven't registered for the workshop, please do so that you can actually get the link. It's a new link, so you can get the link to actually go onto that at 1:30. But I'm going to stay with another question here from Robert Tustin relating to port restrictions in technologies. And there's a question here aimed towards Joshua. Are there any considerations? Have you come across any considerations? What does a ship owner, what does a technology company perhaps have to think about in port interface restrictions for cargo vessels with wind assist rigs as part of work package 2, I guess? You put work package 2, even though you're on the work package 3. But when we are looking at these installations and going into ports, have you been looking in any way, or has as part of this project been looking at in any way how wind assist technologies can impact port operations or terminal operations, cargo operations, etc.?
Yes, so obviously, as the developers of the numerical tools, that's not something we're directly considering. Now, however, it is something that internally we've already discussed. I think I mentioned earlier that SSPA organized a workshop that focused on legislative and safety issues with regards to the installation of wind propulsion technologies, and in fact, those very issues were discussed. So there's a few factors to consider, one of which is, of course, essential, is that the installation of the wind propulsion technology cannot impact the loading or unloading operations for the ship, because that would obviously make the installation of such technologies not very attractive. In terms of safety, there's really a few issues to consider as well, because the reality is you can't simply mount these devices anywhere on the deck, because you're limited in terms of bridge visibility in certain cases, but then also the position and the visibility of navigation lights, which is also, that was another issue that came up during that workshop that we had earlier towards the end of last year. So yeah, and of course, potentially the positioning or how many wind propulsion units that you can place on the ship, has some impact on the ultimate savings that you can realize. But yeah, those legislative issues go really hand in hand with the technical feasibility, because while you may be able to physically put it on the deck, if you can't maintain a proper visibility from the bridge or meet the safety legislations, then obviously it's not, it's useless. It just simply can't be used. So those things have certainly come up as a part of some of of an internal workshop thus far.
Good. Thank you very much there, Joshua. I've got three final questions, so I'll just take these three questions over the last 4 minutes. Gavin, go on quickly.
Yeah, so sorry, can I just mention, following on from what Josh has been saying, one of the ships that's been installed is called the NVA Frisian-Sea, which is a Bumsmar shipping vessel, and they were very concerned about the loading and offloading of the especially the bulk cargoes. So they developed a flat rack system, which is pretty much like the base of a container, and the systems are attached to that. Those are movable onto different hatches or hatch areas. It's also possible to actually put the ventifoil and actually stack that just in front of the wheelhouse when that's necessary to do. So that is certainly a consideration, and I think while the WASP project will be looking at some of that and how that impacts, that port concern was certainly a major factor for Bumsmar shipping and in their application.
Great, thank you. A couple of minutes left, and I've got three questions. Let's see if I can get through them. I've got a question from Joshen Marzi, comparing different conditions. The Flettner rotor creates drag also in operation, but the ventifoil can be folded away. Were these two issues examined? Did you compare those two about the Flettner creating drag? And that goes back to the testing operations. I guess that could be just a very quick answer from you, Sophia.
Yeah, no, we just have to keep it in mind when we analyze the sea trials. So that's the answer.
Okay, good. And I'm going to stay with you on this other question I've got for you here from Maxime Garanel. How to discriminate from full-scale measurements the WASP contribution from the potential increase in power requirements due to off-design condition of the hull and propeller, i.e. reduced drift angle due to the WASP side force, for example. So in other words, I guess it's a system put onto a vessel, but the hull not being directly optimized for a wind assist solution, isn't it?
Yeah, I mean, but what we measure is the whole system, ship and sail together, and the total fuel consumption. So drift and rudder and all this comes into the whole system. So basically we cannot separate it as such.
Okay.
I'm not sure we are interested in that either. I mean, it's good for validation purpose of the numerical tools. It would have been nice to separate them, but what we really want to confirm is the fuel saving of the whole system.
Yep. Yeah. And I'm going to go to Joshua for this one, please, Joshua. Again, for retrofitted ships, the benefits from using a wind propulsion system are limited by the already existing propulsion systems of a vessel. So, for example, for a classical diesel propulsion system, the engine power cannot be reduced that much. In other words, it's difficult to slow the engine down efficiently or effectively beyond a certain percentage. does this limit then what you can do with a wind assist solution? Or do you just accept the increase in speed when you may not want an increase in speed? So can I just get Joshua to answer that very quickly, please?
Yeah, sure. Yeah, I mean, as I mentioned before, ultimately the benefit that you get from the wind propulsion technology is not only tied to the wind conditions, but there's an interplay with the existing propulsion system. So the more limited you are in terms of your control of that conventional propulsion system, then there's less potential for synergies between those two systems. So again, having more flexibility, more capability to depower the engine or to de-speed the engine gives you more capability to take advantage of that thrust and to try and realize, basically to run the engine at a more efficient point. So you're using less fuel, but you're also using that fuel more efficiently. That's the idea. But again, that's a limitation of the existing propulsion system.
Great. And while you're there, Joshua, you might be able to comment on this very last curiosity question about using flywheels as energy storage, as well as for vessel stability. I'm not quite sure where that question is coming from, other than from Nicole Costa, but flywheels, is there any such thing being used?
Not as the course of this of the Wasp project, not that I'm aware of. Yeah, not that I'm aware of.
Okay, good. I'd say thank you to all of our panelists here. We've run out of time. I've managed to end us 1 minute late, so I am disappointed in myself. But if we could all give a very silent thank you to our panelists and speakers today, Gavin, Josh, Sophia, Vasilios, and Orestes, for their input. A reminder about the workshop, which will start in 58 minutes now. So if you haven't already done so and you want to do so, you need to follow that link to re-register or register for that on a different Zoom connection. So I'll say thank you to that. And I can see that Carol from Marin is there, stood there waiting for me to hand over back to her then. So over to you then, Carol. Thank you very much, everybody.
Thank you, Craig.
Thank you, Craig. You said
Okay.
everything already, so no words for me anymore. I hope to see you at 1:30 again for the WISP workshop. So have a good lunch.
Thank you very much. Bye-bye.
Happy Earth Day, everybody.
Thank you.
Yeah, happy Earth Day.